So this is week 58 quiz, and number 3 says a dodecagon is formed by removing 4 squares of side length 60 from a square of side length 289, as shown below. What is the side length of the largest possible square that lies entirely on or in this dodecagon? So we first picture what the square would look like, and it would look something like this. So one side here, other one here. Something like this. And we also know that this side length is 169 because this is 60. This part is 60. This part is 60, so that's 169. And so let's label these two sides as 169 minus x and x. And we also know that this is 60 and this is 60. And we also know that this part over here is 169. And this is a right angle because we know it's a square. We know this red thing is a square. And we know that this is the biggest square because it has to have one edge here and then it intersects here. So this red part is actually supposed to be on here, but I just drew it really badly. And so now we have equation to satisfy this part where this part intersects here and this long part intersects here. And so then we have from Pythagorean theorem that 3600 plus, oh shoot, why isn't it working? Okay, plus 169 squared minus 338x plus x squared, and then moving on, and then this equals, let's say, y. And let's label this part as y. And then we also know that x squared plus 3600, which is just 60 squared because we're applying Pythagorean theorem. And let's say this equals to z. If this is z, label this part z. And, oh, and because it's Pythagorean theorem, we have to square root it all. And also from Pythagorean theorem on the y, z, and 169 triangle, we have y squared plus z squared equals to 169 squared. And expanding this, we get 3600 plus 169 squared minus 338x plus x squared equals, sorry. And then let's put this in parentheses. Plus parentheses. Oh yeah, x squared plus 3600. And this equals to 169 squared. And then we cancel the 169 squares out. So here, and then we combine like terms. So these two become x squared 2x squared. These two become, well, let's not do those two. And then we have minus 338x because it's the only x term, and plus 7200. And let's move this down a bit. Move this down. And this also comes here. And so we know this equals to 0 because we already canceled the 169 squared out. And let's divide this whole thing by 2. And we get x squared minus 169x plus 3,600 equals 0. And we get 169 plus minus from the quadratic formula, square root of, oh yeah, 169 squared minus 4 times 3,600. And we divide this all by 2. And then we come here and then we calculate what the 169 squared times 169. We multiply this out, and after you multiply it out, you get, I don't know if you're gonna use like a calculator or not, but like if you're not supposed to, just calculate it by hand. And you get 28561. Yeah. And then 4 times 3,600, that's pretty simple. That's just 14400. And then we get 16141. And then we put this into 161,461 square root. Oh my god, it's a perfect square, guys. And we get 169 plus minus, what was it again? Oh yeah, the square root. 119 over 2. And we know that, like, x, it doesn't really matter plus or minus, like, what really matters here because it's going to give us the same result. So let's take, like, the plus, and we get 169 plus 119. So you get 1882. So you get 144 as x. Or we can do the other way. And let's erase this work here. Where it's 169 minus 119. And we get 50. And divide by 2 and we get 25. So 25 equals x. Well, as you can see, it doesn't really matter because if we go back here, we label it as 169 minus x and x. So if we input 144, then this side will be just 25 and this will be 144. On the other hand, if we input 1T5, this will be 144 and this will be 25. And because it's just symmetrical, it like doesn't matter because the side length will be the same anyway. And so we have this, we have x, we found x now. Let's just say x is 25. But like either way, the calculations will be the same. I just like 25 better. And then, so now we can see that this is 25. And this is 144. And so to find like the side length of the square, all we have to do is find y plus z because this part is also z. because like we want to be like as like as like symmetrical as we can. And so this part will be Z, and then this part will be Y, and Z and Y, and Z and Y, and that's Z. And note that like we're dividing it on like these points right here. And that'll maximize our area because we're like this square will like maximize our area because we're like making the minimum possible amount of like triangle space that's outside the square. Because if we didn't intersect this point right here, then we have like this extra space right over here that's like not part of our square, and we don't want that. And so we find y now, and just y is just equal to 60 squared plus 144 squared, and this will equal to uh and this will equal to, let me just pull that. Well, actually, we don't even need this. Like, to be honest, like, but whatever. But like, if it doesn't allow calculators, just like um do it by hand. I'm just doing it to like make this video clearer. So that equals 156 squared. And so y is equal to 156. Of course, if you made this as 25, this side is 25, and this side as 144, then then z would be 156 instead of y. And so now we find z, and we get that 60 squared plus 25 squared, and this is pretty easy because we have a 5, 12, 13 triangle if we just divide this thing by 5. And then we get 13 times 5, which is 65 squared from similar triangles. We could also use that on the one above, but like I didn't want to. And so we can find that z is 65. And finally, we add these together and we get 156 plus 65 equals to 221. So that's our answer.